All right, today we're going to finish 3-6 notes. This is our last thing that we will do, take our test. So we're just going to continue functions and getting information. So everything we did last class, you're still going to have to be able to do, but we're going to add a couple things. We're going to add ending behavior and range and graphing the function. So just a few things. This says with no common factors, some of yours will have a common factor. So you will need to make sure that you look at that ahead of time. Is there a common factor or is there not? Either way, the steps are going to be the same. You just need to cancel the common factors first. So we're going to first find and plot y-intercepts. Remember to get your y-intercept, just let x equals 0. You're going to find the zeros of the numerator, which gives us our x-intercepts. You are going to find the zeros of the denominator. That means that those are vertical asymptotes. So remember, when we sketch an asymptote, they are dotted lines, so all our vertical asymptotes are going to come up and down like this with a dotted line at whatever we get. We need to find our horizontal asymptotes. Will also be a dotted line. They'll just be horizontal across. So vertical asymptotes are going to divide our graph into sections. In some sections, the horizontal asymptotes will apply, and in others, they will not. So a vertical asymptote, a graph can never touch, but a horizontal asymptote, if it's in the middle section, can cross it. We'll look at an example of that. You're going to plot at least 1 point between and 1 point beyond each x-intercept. Basically, get a few points so that you know where the graph is going to be. Use your calculator to do this. So on here, use your calculator, plot your function, look at your graph, look at your table to get some other points. And then make sure all of our graphs are going to be smooth curves, not jagged or like points when they're turning. Everything will be a smooth curve, so make sure that you are doing that. So calculators will be handy. Pause if you need to get yours out so that you can look at some things. So here we're going to sketch the graph and find a bunch of information of things that we need to look for. So I'm just going to walk through like all the steps that I just gave you in that order. So here's our rational function we're dealing with. The first thing we want to do is find the y-intercept. So remember, to find the y-intercept, that means that you just plug in a 0 everywhere there's an x. So if I plugged in 0, so this is gone, I have 8 over -2, so that gives me -4, and they're an ordered pair. So you have your graph right there. I'll plot mine at the end, so you could plot the point 0, -4. You know what your y-intercept is. For our x-intercepts, we set the top equal to 0. And solve for x. So if I set 8 minus 3x equal to 0, solve for x, and we get 8/3, so I'd have 8/3, 0. And then next we want our vertical asymptotes. So for the vertical asymptotes, remember we set the denominator equal to 0. So I'm going to have -2 plus x equals 0. So x is going to equal 2. So what I would do right here at x equals 2, I would draw in, so if you had your graph that you have right there, I'd go to where x equals 2 and I would draw in my dotted line because I know it's a vertical asymptote. My horizontal asymptotes, remember to do horizontal asymptotes, you compare your degrees. So in our case, our degrees are n equals rd, they're both 1. So that's where you're going to make a equation out of our leading coefficients right there. So that's y equals -3. So in my graph up here, or your graph, I would go to where y equals -3, and I would sketch in my horizontal asymptote. So, whoops, already the additional points. So what I would do for additional points, what you look for is, let me erase this right here. Okay, so when you're looking at additional points, what you want to do is put this in your calculator. So I would put this in your calculator. You can get your graph. Make sure you put parentheses around the top and the bottom. I also suggest you pause and make sure that you can get this. So notice I have my horizontal asymptote right here at -3. I have my vertical one at 2. My y-intercept is plotted. My x-intercept is plotted. And then you just can find a few other points approximately. It looks like 4, -2 might be a point in here we could graph. Find a couple points and draw in smooth curve, not touching your asymptotes. If your graph touches or crosses your asymptotes, I would count off if you were graphing it. So make sure that you are able to do that. So once we have our graph, we're going to answer some questions about this. So from our graph, we want to figure out our ending behavior. Remember, ending behavior is what is y doing as x approaches infinity, and what is y doing as x approaches negative infinity. Okay, that's our ending behavior. So our ending behavior here, you can see this graph is continuing and going to, but never going to touch -3. So as x is going to positive infinity, it's going to -3. Same thing over here, my ending behavior, we can see it's never going to cross it, so -3 for our horizontal asymptote. Our domain, we know how to find domain. Also, remember domain is where our vertical asymptote is, so our domain here would be -infinity to 2, union 2 to infinity. Our range is our y values. We haven't done that, but look at your graph. It continues going down, so it starts at -infinity. It goes up, but it's never crossing that horizontal asymptote, so it goes to -3 and then starts again and goes to infinity, continues going up. So these are all things that you're going to answer on your assignments today. Next, we're just going to do the same thing here. You can look, we can do a little bit of, we want to make sure we don't have any common. So I have x minus 4 on the bottom. I could factor out an x, and it's x minus 3. Nothing I can cancel, so we're good. We're going to start doing the same thing. Y-intercept, so remember for your y-intercept, you would let your x equal 0. Well, if I plugged in 0 everywhere, I would be left with -4 on top and 0 on bottom. You can't have 0 on bottom. This would end up with -4 over 0. That's not possible, so there's not any. So it never crosses the y-axis. My x-intercepts were set the top equal to 0. So if I solve for this, I would get x equals 4. So 4, 0, so I'd put a point at 4, 0 for my x-intercept. My vertical asymptotes, again, we're setting the bottom equal to 0. I already had that factored. I factored out an x. Set each of those equal to 0. So this would give me x equals 0. This one would give me x equals 3. So here's my vertical asymptotes. So at 3 and 0, I would draw in your dotted lines for your vertical asymptotes. Horizontal asymptote, remember you're comparing your degrees. So in this case, my n is less than my d. So when our n is less than our d, it's just y equals 0 from the rules we learned last time. So at y equals 0, I would draw in a dotted line. Then you're going to look at some additional points, and we want to make our graph. So in here, you can see that I don't have my asymptotes because I copied this off my calculator and it doesn't show them. So you would need to draw in at x equals 0, at y equals 0, it looks like it touches it, but it really shouldn't on your graph, and at 3. So your calculator is getting so close to the asymptotes that it's not distinguishing between them, but you can see that they're there. When you graph them, you need to make sure that they're not touching it. So here you would have your, our x-intercept was at 4 right here, and then try and get some other points on there. Then this one, try and get close to that, so it looks about like at 2, 1, not exactly, but sketch some points in there. Okay, a lot of yours are going to be multiple choice, pick the right graph, so you should be able to do that. Ending behavior, so again, what is y doing as x goes to infinity? So as x is going to infinity right here, it's going to 0. Okay, what is y doing as x goes to negative infinity? Again, in this case, it's also going to 0. Okay, not there yet. So our domain, again here, negative infinity to our 0 because that was one of our asymptotes. And then 0 to 3. And then 3 to infinity. So we learned how to find domain last time. I'm just kind of looking at where my asymptotes are. Our range, again, it starts at negative infinity, goes up, goes to 0, and then 0 to infinity. It keeps on going. Okay, one more. This one a little more challenging. Let's go ahead and look at, make sure there's nothing we need to cancel out. So on the top, I could factor out a 3x, which would leave me with x minus 4. On the bottom, if I factored, it would be x minus 3 times x plus 1. So there's nothing that could cancel. So if we look at it, our y-intercept, so our y-intercept, if I plug in 0 for my x, I would get 0 on top. Okay, on bottom I would have -3, but that would just be 0. So my y-intercept is 0, 0 for a point. Our x-intercept is setting the top equal to 0. So we factored that already, 3x times x minus 4. If we set both those equal to 0, we would have x equals 0 for 3x equals 0 is x equals 0, x equals 4. So our intercepts are 0, 0, and 4, 0. It's okay that these are the same. You just put 1 point there. Vertical asymptote set the bottom equal to 0. We also had already factored that, x minus 3 times x plus 1. So 3 and negative 1. Horizontal asymptotes, you compare our degrees, in our case n equals d. So again, we're going to make a fraction out of our leading coefficients here, so y equals 3. Plug it into your calculator. Again, when you plug it into your calculator, make sure you put parentheses around the top and parentheses around the bottom, and we'll graph it. So again, I need to add in at 3 right here is a vertical asymptote. At negative 1, I have a vertical asymptote. And at y equals 3, I have a vertical asymptote. So you can see our vertical asymptotes. Remember, a graph can cross a horizontal asymptote. So the last example, I didn't talk about it, but at 4, 0, we actually had an x-intercept. That was okay because it could cross that horizontal asymptote. So here you can see my middle section. It goes through our 0, 0, which was an intercept, our 4, 0, an intercept. And then we need to find a few other points. They might not be exactly, but make it kind of close. Know this graph approximately, is at negative 2, it's about 5 or so. It doesn't have to be perfect, but get it in there close. Make sure we know where the turn is happening in here. So it's crossing the horizontal in this middle one. That's okay. It can do that. Okay? It's not going to be able to ever cross vertical, but it can cross horizontal. It does that a lot in the middle section. So our ending behavior, again, y is approaching what as x goes to infinity. So again, remember we have a dotted line right here at 3. So as x is going to infinity, y is going to 3. Same thing here, as x is going to negative infinity, y is still going to 3 as x goes to negative infinity. Our domain, just like we've done before, this would be negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. Our range in this case, though, even though I have a horizontal asymptote, because my middle section goes through it, my range is negative infinity to infinity because it actually crosses this line right here, so it's not exempt from being in our range. Okay, so your assignment today, that's everything that we're doing. Your assignment is on a WebAssign where you will fill in everything like what we did last time. So it looks like it's really long just because each question has so many parts to it as far as your domain and intercepts and your asymptotes, and then choosing the correct graph. A couple of them, they actually will give you a graph, and you just are going to get information from the graph. So let me know if you have any questions. Have a great day.